Hey folks, I love it when I find examples of math on social media with stuff that sounds interesting. So in this particular case, I ran across this meme that says percentages are reversible. Oh, by the way, let's see. Somebody had earlier posted what's a little known but obvious fact that will immediately make all of us feel stupid. Now, I don't know that this is something that should make us feel stupid, but um, it says percentages are reversible. 8% of 25 is the same as 25% of 8, and one of them is much easier to do in your head. So, first of all, the question arises, is that really true? Because one of the things that I have a real pet peeve about is that people believe any meme that they see. As long as it's in the form of a picture, whatever words are on it, people believe. I do not like that. I think that we should investigate a meme before we hit like or before we pass it along to others. And this one is certainly verifiable. So 8%. So is it true that 8% of 25 is the same as 25% of 8? Well, first of all, let's write these guys out mathematically. 8% of 25 means 0.08. That is what 8% is as a number. By the way, percent means out of 100. So what this means is 8 over 100. And when we write out 0.08, it means that 0.08 means 8 out of 100. If it was zero point 0.8, it would mean 8 out of 10. And if it was 0.008, it would be 8 out of 1,000. Anyways, so 8% is 0.08. The of means multiply, and then we've got the 25. And that's how we would write out that problem mathematically. Then over here, we've got 25% of 8. Let's see how we'd write that out. That'll be 0.25. That's 25 out of 100. And that will be times just 8. So far, they don't really look like they're the same. And I would think that many people might say, well, wait a second. I don't see how those two could be the same, or what is it that makes them the same? Well, watch this. 0.08 can actually be rewritten as 8 times 0.01 and then times 25. And 0.25 can be rewritten as 25 times 0.01 and then times 8. Oh, by the way, we need to switch to a new color. I like these things to be as colorful as possible. Okay, so anyways, so now you still might be saying, well, but they still don't look the same. This guy is in a different order than this guy. Well, thank you to my old friend Dr. Zuckerman, who pointed out that there's this handy dandy little thing known as the commutative property. The commutative property is one of those little things that we learn in school that everyone wonders, why do we need to know that? And it's a long word, and the concept seems so complicated. The way it's presented to us in math class is that if we have, by the way, there's a commutative property for addition and multiplication. We're talking about the multiplication one. And what it says is if we have a times b, in other words, any number a times any number b, that will be exactly equal to b times a. And all the commutative property is trying to say is that when we multiply two things together, it doesn't matter which comes first, we're going to get the same result, also known as a product. Now, what about when you have three separate things? Well, it turns out that the commutative property works for that, and it also works for 4 or 5 or 6 or 7. If you have a bunch of things multiplied together, you can change the order around and you will always get the same product or result. So when it comes to the when it comes to these guys, if I just rearrange them a little bit, then they'll look exactly the same. And maybe I'll give them all a different arrangement so that you can see this. So I can rearrange this guy here to be 0.01 times 8 times 25. And I can rearrange this guy to be 0.01 times 8 times 25. And if I do, I don't even have to do the multiplication. I can see that, yeah, those two are the same. They're equivalent. Okay, so we're in the final stretch. So now that we know that they're equivalent, this guy says that one of them is much easier to do. And maybe you were thinking to yourself, well, really? Is one much easier to do? And I'd say, yeah, one is much easier to do. But before I go on, why don't you pause the video? And why don't you take a moment and think for yourself, which one of these do you think would be easier to do? And see if you can do it in your head. Okay, I'm hopeful that you paused the video. Now I'm going to give you my thoughts. My belief is that 8% of 25 is going to be pretty tricky. I think 25% of 8 is going to be a lot easier. I am hopeful that some of you recognize that 25% is the same as 1/4. And if we have 8 of something, 1/4 out of 8 is pretty easy to figure out in your head, I believe. And I apologize if I'm offending you in some way. So if we say something like 1/4 times 8, 1/4 of 8 is 2. And that will be your answer. Okay, so now what you have is a handy dandy little trick that you can use forever and a day. If you ever have 2%, if you ever have a percent times some number, and you can't figure it out, you can always reverse them. So for instance, 8% of 25, you can make it into 25% of 8. Yay! That's kind of fun. Anyways, hopefully, by the way, for one of the reasons I wanted to make this video is because of so many people that I read complaining about the Common Core. And why can't they just make it easy? Why can't they just show the kids the math the way we learned math? I'd like to point something out to you folks. How many of you think you are bad at math? And if you do you really want us to teach kids the same way you learned? Okay, so that's one starting thought, okay? And on the other hand, if you don't believe you're bad at math, but you look at the other adults around you and you find that they're bad at math, do you really want us to teach the kids the way that they learned how to do math? I'd say no is the answer. One of the reasons why in Common Core we spend all the time talking about the theory and the options is because we want people to be using logic and reasoning when they're solving math problems, not just memorized procedures. We want people to have an understanding of how the numbers work, we call it number sense, and how the various operations work. And what properties are available to us and which ones work and which ones don't. And more important than that, we want kids to be able to investigate what works and what doesn't work, and for them to get a sense of what works on their own, not just to have a series of facts and procedures that they are given by their teacher and they memorize. Okay, anyways, that's my 2 cents on why we learn Common Core math. I hope you enjoyed this video. That's about it. Take care, guys.